All right, so let's keep working with our tangents. In part A, we are told that segment YZ and XZ are tangent to the circle. So here's YZ tangent to the circle, so perpendicular to the radius. Here's XZ tangent to the circle. We can see it's perpendicular to the radius. So what if we have two tangents that share an endpoint? See how these both of these tangents end at point Z. So what is the relationship between YZ and XZ if they're both tangent to the circle and they both share that endpoint? Well, why don't we explore that? So here is what we know. We'll just list some things off. First, we know that XT is going to be congruent to YT. Those are both a radius of the circle, and we know that all radii are congruent. That's good to know. All right, what else do we know? Let's draw in segment ZT. What this lets us do is kind of think about two separate triangles right here. When we do that, now I have a segment ZT that's in both triangles, and it is congruent to itself. So ZT is congruent to ZT. Remember that reflexive property? All right. Well, what else can we say? Notice that we have two right triangles. So triangle XTZ and triangle YTZ are right triangles. So we've got this triangle with a right angle. We have this triangle with a right angle. When you have right triangles, they are congruent if they have a congruent hypotenuse and a congruent leg. So we just showed that the hypotenuse ZT is congruent. ZT is the hypotenuse for both triangles. We also showed that they have a leg that's congruent. That leg happens to be a radius for the circle. So because there we have congruent hypotenuse and a congruent leg, that means that we have congruent triangles. So triangle XTZ is congruent to triangle YTZ by the hypotenuse leg theorem. Well, when you have congruent triangles, all the corresponding parts are congruent, and XZ is a corresponding part to YZ. So that means that YZ is congruent to XZ because of CPCTC. All right, so now anytime that we have two tangents that share an endpoint, those segments we know are congruent every single time. So we can apply that knowledge. So part B, I'm going to just redraw this just so that it's a little bit easier to label because we just labeled that picture a bunch up there. So here's my circle T. Why don't you guys redraw this with me? Here's XT, and then I'm going to draw a tangent over here, and that is YT, and we have Z. All right, so they said if TX, so TX is 12, and TZ, oh, looks like we want segment TZ in here as well. TZ is 20. What are XZ and XY? I'm sorry, XZ and YZ. Well, XZ is part of this triangle. So if we look at that triangle, we know it's a right triangle. Here's X, here's T, here's Z. We know that this is 20, And we have a 12 over here. So let's find XZ. Pythagorean theorem, great. Or do we have a triple? 12 and 20 can both be divided by 4. That gives us a 3, gives us a 5, which makes this side a 4. We have a 3, 4, 5. Because we divided by 4, let's multiply that back up, and we know that XZ is 16. Well, because we have two tangents sharing an endpoint, we also just learned that XZ and YZ will be congruent, so YZ is also 16. All right, so our theorem, if two segments with a common endpoint exterior to a circle, so a common endpoint in this example here, it's Z, it's exterior, which just means it's outside of the circle, are tangent to the circle, then the segments are congruent. So here's our picture right here. You have two tangents that share an endpoint outside of the circle. The theorem tells us that those will be congruent. So that means that AB is congruent to AC.